I don't have any pretty pictures. Those pictures of Yosemite were wonderful. I want to thank the organizers for this workshop. This is one of the things I love most about my job, actually, is having the opportunity to work with people who are not necessarily doing exactly what I do. I think as a group, we're making lots of great progress working on these incredibly complicated problems and having a lot of fun doing it. Okay, so I live here in Illinois, although a couple hours south of here. Let's see. There we go. I don't think of myself as somebody who works on ecosystem service valuation, but I have wound up doing it anyways because it has become something that environmental economists get involved in pretty often. And I think that I'm really impressed by how exciting all the work is going on in this area, both just valuing ecosystem services per se, and also evaluating changes in them. You know, if we do something to make things better, how much is that worth? If we do something that makes things worse, how much of a loss is that? Some examples of things that that I've sort of been involved in, and I'll mention them first because I'll probably end up sort of coming back to them as examples as we go along. I worked with a student. He was a beekeeper. Now he's in New Zealand, and he wanted to study the economic losses associated with colony collapse disorder. So, you know, how do economists think about ecosystem services? It's through these three stages. You know, something happens, there's a change in the physical system. You know, in this case, lost pollination services, lower crop yields, and then people don't like that. There's some loss from the human perspective. Here, it's lost economic surplus in food markets. I've done a lot of work on land conservation and restoration, species and habitat protection. So if you set some land aside or set it in permanent conservation, you might get increased populations of some species. People get value from that, lots of different kinds of values. And I guess one thing I'd like to point out, and this speaks a little bit, somehow Juha, I was thinking about this when you were talking, people are not as narrow as natural scientists fear we are. We don't only like bears and tigers, although we really do like bears and tigers and elephants a lot, but you know, we also like weird assemblages of not particularly charismatic things. And so we gain lots of values from species, aesthetic values, cultural values, recreational values, existence values, lots of them. And we can value those things. I'm doing some work with people in the city of Chicago studying green stormwater controls, things like rain barrels and rain gardens, and not the big tunnels underground, although eventually the projects will integrate. What if you do both? Some of the changes in physical services there, you can have increased flood control, you can have water purification. Why do people care about that? Well, improved personal safety, increased health, lots of benefits. I'm working, Patty Vitt, who spoke earlier, we're working with some colleagues on a grant proposal to study invasive plants and which ones are more invasive than other ones, and who cares? You know, then they call, you're an economist, will you work with us? And it's great. So, you know, so we're in the process. Dick, I loved your turn, the sort of collective cognition. We're engaged, I think, in collective cognition about this, where I ask them, okay, so why do people care about burning bush, invading a forest? And they sit and think about it for a while, and we're coming up with some things. You know, it affects forest yields. We're still working on it. But there are changes in human values associated with those physical changes. So all of this is really profoundly multidisciplinary. It really doesn't work to staple stuff together, to have the ecologist do something and then the economist, and off you go. And that makes it both really exciting research, but also very difficult research. I think it's incredibly important, though, not to give up on valuing ecosystem services. If we have values, it will facilitate the functioning of ecosystem service markets and trades. It will enlighten payment for environmental services programs. I still haven't figured out how we have payment for environmental service programs where we don't know what we think the services are worth. It's complicated, right? It also allows more complete cost-benefit analyses of policies. So if EPA, as it did a couple years ago, analyzes proposed new stormwater control policies, and we don't have a value to place on improved aquatic habitat and streams from stormwater controls, that's a zero on that side of the benefits. And there are all these costs, and then we don't have values for a bunch of the benefits, and it's not that we say, we're going to make something up. No, it's just a zero. So I think it is actually important, even though it's difficult and controversial, I think it's important to do the values. But there are huge practical challenges that we all wrestle with on all of these projects. And so what I want to do is to talk about some of these, at least 3 and maybe 4 if there's time. You've got cards, right, to keep me from going too long. So production functions often haven't been estimated. Economic valuation is difficult. There's a lot of spatial heterogeneity involved in ecosystem service values, and there are feedbacks. Okay. First of all, this is a challenge from me to my non-economist colleagues. We need your help. Often I'm working with a hydrologist on this stuff, studying stormwater controls in Chicago, and that graph, I'm sorry, it's so terrible. On the x-axis it says time, and on the y-axis it's sort of stormwater flows. And so when a storm starts, there's not a lot of flow, and then there's this sort of this surge. And when you have an urban environment, there's a big surge, and if you improve the hydrology of the area, then it spreads out. And yeah, I'm not a hydrologist, I'm just learning. So they can tell me this kind of thing, but how can I take that to people and say, what are you willing to pay for that? What are you willing to pay for that? Well, I don't know. What does that actually mean for life? It's important, but it's important because it affects flood frequency. It's important because it affects stream flow regime. Oh, who cares about that? Oh, because that affects the species that live in the streams. And so there's always, with many of these things, and how you mentioned this, there's a lot of work to be done with us working collectively to figure out how to measure, and John also talked about this, to measure outcomes that people care about, or at least to figure out some kind of function that relates something that's typically measured, like parts per million or whatever, to things that people care about. It could be a really complicated function, but we need help getting from the science-based metrics to things that people care about so that we can begin to place values on these things. I guess another reason that it's complicated is if you just measure concentrations of nutrients in a lake, more is maybe bad, but it's bad in a complicated way, and the things that humans care about might be a wildly discontinuous function of this thing that's easier to measure. So for all these reasons, we need better functions. So in the case of invasive species, they look kind of the same. That's burning bush. That's purple loosestrife. They're both invasive and they're both lovely, beautiful. So if you go to people and say, well, there's this big spread of purple loosestrife, they'll look at the picture and they'll say, oh, that's great. Can I have some? And so because of that, we need to measure these. We need to measure the things, the loss in ecosystem function, the loss in services, and communicate that. And with the hydrology stuff, we need to turn it into measures like annual probabilities of floods of different severities, or expected number of days that surface water is so dirty from a combined sewer overflow that you can't go swimming, that kind of thing. And it's not impossible, and we do it, but it's definitely work. And to the extent that some of this stuff could be done up front, then every time a team gets together to work on a project, we don't have to start from scratch. So that would be helpful. So this is just a call for more of that, more of us working together to figure out which physical measures translate well into human values, and a call for wide-scale sort of production functions. Sometimes I talk to ecologists and they're really unwilling to give me anything general because every site is different. And that's certainly true. Every site is different, but every person is different, and we have demand functions for products where quantity demanded is a function of price. And it's painful, but we can do it, and it would be really helpful. So now us, we have a lot of work to do too. One thing that we end up doing a lot of is resisting pressure from non-economists to just use avoided cost measures. This has already been mentioned. In the case of invasive species control, one thing that people will tend to do is to say, well, the benefit of invasive species control is the avoided cost of eradication. Well, that's part of it, but that's a lower bound estimate. It's only part of what's going on here. The benefit of flood control is the avoided cost of repairing the buildings that got damaged by the flood. Again, that's part of it, but it's much more complicated than that. And the values tend to be higher than just avoided cost measures. So, we'll bear the torch and keep pushing these projects towards using more complicated valuation tools so that we can get full assessments of the values and not be selling these ecosystem services short. As Juha mentioned, sometimes valuation is really controversial. As I mentioned, I do a lot of work on species and habitat. And the community that works on species and habitat conservation is highly resistant to monetary valuation, highly resistant. Because, who's to say which bird is more valuable? And it feels wrong to place dollar values on lives, or to say that if you gave me $100, sure, go ahead and extinguish elephants. It just feels wrong. But if we don't have dollar values, and economists, we don't really care about money, really, no more than anybody else does. We have to pay mortgages and stuff. That's not the point. Dollars are just useful, we could call, use wampum or I don't know, Pokemon cards, something. It's just a way to facilitate thinking about trade-offs between things. How much are you willing to trade off this for that? And if we have dollar values, they can go into cost-benefit analyses so the ecosystem benefits aren't sold short. And it also allows analyses of trade-offs between ecosystem services. So there are lots of ecosystem services that we love and care about, and we can't always have them all. Sometimes we have to make choices, and not just choices between economic activity, malls and shoes and tacky things like that, but trade-offs, choices between different good environmental things, and that's hard to do. Just to bring up the example of biodiversity, what tends to be used as the sort of metric of what you've accomplished are sort of numerical measures of how many species are protected, species richness, species evenness. There are so many different metrics. I couldn't fit them all on a slide. This is a sort of pictorial example, illustration of two different ones. The one on the left has more species richness. It has 3 different species. But the one on the right has more evenness. So the one on the left, there's only 1 ladybug and 1 dragonfly. And so they might be sort of at risk of going extinct. The one on the right might be more resilient. So what do we actually care about? It's so frustrating when you work on biodiversity or species. How do we choose when we have to make choices? How do we choose? If we're interested in cultural, spiritual stuff, species richness might be the right metric. But if we want ecosystem resilience, maybe we want to be looking at metrics of evenness. And if we don't wrestle with it at all, then we're just making decisions in the dark. Which is not to say we haven't done an evaluation, but it's been very limited of biodiversity, so to speak. There are a bunch of studies on willingness to pay to save particular species, but always kind of on a one-by-one basis. There are some studies of willingness to pay to save particular assemblages, like coral reefs. and attempts to value them based on pharmaceutical value, but that's not really why people care about species, really. It's more than that. So I think a lot more needs to be done, not just on biodiversity valuation, but on valuation of lots of things. Even though, as John Haim pointed out, there are tons of papers on valuation of environmental amenities. Many of them stem from an era when valuation was done because EPA wanted valuation done of things related to air pollution, water pollution. They're not really ecological. So we're missing a lot of things, and we haven't done much that addresses trade-offs. There are trade-offs. These are specific birds, wood thrushes and bobwhites. And a colleague of mine has studied, how different kinds of grassland or actually woodland versus grassland favors different bird assemblages. They're all good, but how do we choose? How do we choose what to restore to? So we need more research on that. I'm not going to get to my fourth point, but at least I'll talk about spatial heterogeneity. This is a big problem. It's a big challenge, and I think it's one we have to wrestle with. Ecosystem service benefits are really spatially heterogeneous. I was thinking this morning in the discussion about wetlands and nutrient farming, the same wetland will produce will harvest different quantities of nutrients in different places, and the value of that wetland is different depending on where it is. Sometimes the spatial heterogeneity is idiosyncratic and then we're doomed, but sometimes it varies systematically according to rules of thumb. Proximity to a river, proximity to a lake. If you're thinking about sediment control, that's a big part of it. So if we can come up with we have to do some complicated studies of spatial heterogeneity of benefit production. But if we can do that and then derive some rules of thumb and incorporate them into ecosystem markets, that would be great, because then those markets could be much more cost effective and really capture some of the variation in what society is really getting out of different practices in different locations. Ecosystem service benefits are also spatially interdependent. So I have a colleague who worked studying erosion control benefits, and the erosion control benefits on one parcel depend on what's going on in the parcels next to it. So you can't just say putting this parcel in CRP will yield these erosion control benefits. It depends on whether the parcels just up the hill are also in CRP. Species conservation. The species conservation benefits of one parcel depend on whether it's connected to a larger reserve or whether it's sitting in the middle of an ocean of corn and soybeans. We can deal with that. Markets can be complicated. We could have a market where the payment you get for protecting a parcel of land depends on what's going on around it. We talked about this at that USDA conference. So again, we need to think about this spatial heterogeneity because there's a lot of potential improvement in market functioning if we can capture some rules of thumb about how those spatial interdependencies work. And then finally, I just want to put in a plug for the fact that values, how you alluded to this, values also depend on proximity to centers of human population. Not everything, we love elephants no matter where they are, but some ecosystem services, people get more value out of them if they're close by. And The Economist in me believes we should pay attention to that. So I think we should try to identify robust rules of thumb of these spatial factors. And as a community, we're starting to work on that, but I think there's more to be done, more exciting and useful work to be done. I'm going to have to skip my last comment because I'm out of time, but I think about feedback effects. Because if you make people better off by making the lake cleaner, they might go fish more. Or more people might move there. And so this is a next generation concern. That's why I put it last, so I could squeeze it out if I ran out of time. But someday we have to start worrying about feedback effects in measuring ecosystem services. And I'll stop talking because I know we're all running late. So thank you very much.